Hi, in this video, I introduced the V. So we define the V as 1 over 1 plus I. So I is the effective rate of interest, and suppose the I is constant. So assuming effective interest rate I is constant, we say the 1 over 1 plus I as V. So we don't have any name for V, but maybe V can be called, discount factor. Actually, it does not have any name in the book. So the notion is that this is the the inverse of 1 plus I. So that means the V, if we have the V dollar in a year, and it becomes $1 after a year. So the 1 is discounted to V for 1 year later, 1 year before, sorry, the 1 year before. So suppose I is equal to 5%, then the V is equal to 1 over 1.05. So that means the V is equal to 0.9524. So in general, if interest rate is positive, then V is less than 1, maybe to be exact, between 0 and 1. Yeah, so that means the 95 cents, actually 95.24 cents, that becomes $1 after a year if interest rate is 5%. Yeah, so so V is convenient when we think about the present value of $1. Okay, so the next example, if the effective rate of interest is I every year, and the capital A of t is equal to 1, here the lowercase t is fixed number for now, then what is the present value? The present value, PV, is A of 0. So this is actually the t years earlier than the A of t. So that means 1 plus I to the negative t's power times 80. So this is 1 plus, okay, so capital A of t is equal to 1. So the entire quantity becomes just 1 plus I to the power negative t. And this is just a V to the power t, because V is 1 over 1 plus I. Yeah, so in terms of the time diagram, so-called time diagram, so if we have the time point 0 and the time point t, and the accumulated value is 1, the present value is the V to the power t. Yeah, so the V to the power t, 1 year later, this becomes the V to the power t minus 1, okay. And 2 years later, so this becomes V to the power t minus 1 and t minus 2 and so on. And finally, this becomes $1. Okay. So the $1 is worth the V to the t's power t years before. So you can imagine the V is a somewhat convenient notation. Okay, so now that we think about slightly more complicated example. So suppose that the effective rate of interest is 10%. So that means I is equal to 0.1. So how much deposit is required today to get payments of $100 at 2 years from now and $200 at 3 years from now? So that means that we have time point 0, that is today, and time point 1 and 2 and 3, and we deposit some amount. Okay, some amount, maybe I would say X. So the how much, so we write this as X, and we receive the $100 at time 2 and $200 at time 3. Okay, so this is T year. So that means to receive $100 at time 2, that we need the 100 times the V square at time 0. And to get $200 at time 3, that we should have the 200 times V cube at time 0. So that means the X amount we should have today be equal to the 100 times the V square plus 200 times the V cube. So what is V? The V is 1 over 1 plus I, and I is equal to 0.1. So that means the 1 over 1.1 square plus 200 times 1 over 1.1 cube. Okay. So this is actually equal to 82.64 plus 150.26. So this becomes $232.90. So in this way, using V, we can calculate the amount X.